Hi guys, Godwin here. It's 1:24 a.m. I'm wearing my Lasallian engineer shirt and I'm feeling the engineering spirit because I think I have to. I need that spirit. The next topic we're going to discuss is something that's really confusing for everyone. And I think I can say that. I think I can say that. It's clipper and clamper circuits. So, of course, the main star of the show, the main component that's in clippers and clampers are is the diode, right? That's comparable to a valve. It lets current in one way, which in this case, the way I've drawn it is from left to right, but it doesn't allow current the other way, right? So, this component that I've drawn actually is what's called an ideal diode, right? There's nothing in there. There's no hidden charges, no nothing like that. But most probably in the quiz that we're going to have soon, uh, we're going to encounter these kinds of diodes, the ones that have like SI or GE written near them, and those are not ideal. So what they basically are, I'm just doing this right now, so I don't have to address it later in the video. They're basically ideal diodes, but they have a voltage drop. So that's an ideal diode. And then they attach a voltage drop to it. In this case, silicon has a voltage drop of zero point 0.7, while germanium, if this is GE, has a voltage drop of zero point 0.3 volts. Right? So just getting that out of the way because the problems here, the examples that we have here, they're all ideal. So you can just replace them with a non-ideal one, and it will follow one of the one of the examples that we're going to give. So before we start off with anything, I want to make sure that this video is quick enough, so it's digestible enough. Let's say when you're cramming for the quiz, please don't cram. So we'll have just one input, one uniform input for all of our examples. So this input is a sine wave, of course. Its peak voltages are -5 and 5, of course. And then of course, for the other things, for the other examples here, almost every other example here has what we call a bias voltage, bias volt. And basically, it's a voltage that offsets. It's either one of the lines that we have, a clipping line, clamping line, or something like that. And it's just, it's just uh drawn as a voltage source. Okay, so our bias voltage here, oops, what's that? Our bias voltage here for everything is 3 volts. So whenever we encounter something like this, uh, we know that it's going to be 3 volts. And periodically, I'll be switching the polarity. So it can either be 3 volts or -3 volts. I'm just getting that out of the way. So with that out of the way, we can start with clipping circuits. So what we have here is the simple series clipping circuits. And so let's just try to analyze what uh what these what these output waveforms are like. So first we have a simple series clipper. Of course, the left side is the voltage input, and then the right side is where we measure the voltage output. So if you see here, the voltage output is measuring the voltage that's going across this resistor, right? And so this diode right here, it only allows current to flow if, what do you call this? If the, of course, if the current is going the right way, right? From left to right in this case. So, it only allows electricity to flow in the positive half cycle of this waveform. So this is the input waveform. This is gray for every example that we have here. And I'm just going to write down our output waveform, of course, since it only allows the positive half cycle of the waveform. Since let's say for the negative one, the polarities are reversed, it won't allow it because it's in the wrong direction, right? And so it's going to follow the positive. Oh my goodness, it's going to follow the positive half cycle, and then it's going to stop because at this point, our voltage our voltage is negative, and so our current is also negative. And so it's going to follow just zero, since this resistor experiences zero voltage across it. Yeah, that's the correct preposition. The output is just, oops, it's just a bump up, and then boom, a straight line, right? And so for the other case, then this one, the diode here is reversed, right? So if current flows this way, it won't happen, right? The current will get blocked. And so what actually is followed here is the negative half cycle, because now we see that it's in the correct position, right? And so when when sorry, in the positive half cycle, this resistor experiences zero voltage because it can't get through the diode, right? So it's just like that. Sorry, it should be on the x-axis. There we go. And then on the negative half cycle, everything is normal, right? Because current can pass through the diode. So it's just like this, right? And so, that's pretty easy, of course. But what if there's a bias voltage, right? So I've notched the things here already, just so we have, what do you call this? We have a reference of where the bias voltage should be. Remember, this is like 5, and this is 3. This is -3. This is -5. And so, what this bias voltage does is, if you look at it, if you can separate this, this is just our simple series flipper, right? This is just the same thing as this, and this is just the same thing as this. Oh, this is just the same thing as that, right? And so the thing that's offsetting everything is this voltage source right here. In this case, this is the 3-volt bias voltage that we have. And so if you look at it, this is positive, this is negative. Excuse me. That's positive, that's negative. So if you think about it, this can be actually combined into the voltage input, right? It just adds 3 volts to everything, right? It just adds 3 volts to everything. So instead of just this starting at 0, this peaking at 5, this going down at 0, this going down further into -5, and this coming back to 0, is now going to be 3, 8, 3, -2. Yes, -2 and then 3, right? So it's like everything was translated up. But the point is, this what do you call this? This series clipper, it's going to clip whatever is negative, right? It's going to remove whatever is negative. So it doesn't go down below. It doesn't go down to -2, right? We did say -2. It's not going down there. Instead, it's just going to cap down at 0, and then it's gonna climb up back to 3, right? That's what we wanted. And let's say the polarities are reversed. So instead of that being the long one, it's now this one, right? So now the polarities are negative, positive. This functions like voltage drop. So instead of adding 3 to everything, we subtract 3 to everything. So instead of 0, 5, 0, -5, 0, it now becomes -2, 3. Wait, I'm sorry. Hold on. -2 plus 5. That's 3. And then it's going to come back to -2. And then it's going to come down to -8. And then it's going to return to negative, wait, -3 to -3, 8, -3. There. Don't know, I'm having so much trouble. Maybe it's because it's 130. So instead of going like this, right? Oops. We expect it to go like this. What we did say before was that it only allows positive voltage, right? So instead of going like this, oops, let's scroll down. Instead of going like this, whoa, it only allows this to come through, right? Oop, allow this, and then everything is 0, right? And so that's the same thing with the other one. But instead of allowing positive charges only, it's going to allow only negative charges. So in this case, the bias voltage is positive still. This is positive 3. So we're gonna shift everything up. But oops. But I did say that only negative charges are allowed. So instead of doing the whole sine wave, we're only going to allow negative voltages. That's it. And then if we do the same thing, if we reverse the polarity and if we reverse the polarity, make this one longer and this one shorter, is going to be positive, negative. That's going to function like a voltage drop. So instead of uh so we're going to translate everything down. Whoa, gonna translate everything down, but we're only going to allow negative voltages. So it's going to do like this, then that, and then bump up, and then that, right? So we know this is I think this is called the clipping line, right? Where, sorry, no. This is this is the start of the ano. This is the start of the waveform. The clipping line is where it stops accepting the waveform, right? So the clipping line everywhere here should be 0. And so we're going to change that. We're going to go to parallel clippers next. And I think this is a bit harder to analyze. So let's try it out. Instead of the resistor, the instead of the resistor being the one that's measured here, right? The one that's being measured now is the diode, right? So a diode here can only become an open switch or a closed switch, right? In this case, everything is ideal, of course. So now let's try to analyze it. If it goes, what do you call this? If it goes like this, right? If there's positive current. So if there's positive current, of course it's going to be let in through the diode, through the valve, right? And if that's let in, the valve is going to function like a closed switch, right? So it's kind of like this. And this is a closed switch. So what are you going to measure here exactly, right? What's the voltage between 2 points in a closed switch? What's the voltage in a short circuit? Of course that's 0, right? So for the positive half cycle, it's not going to accept anything. But here now, in the let's erase this. In the opposite current, it's not going to allow it's not going to allow voltage current to come through, right? Since it's in the wrong direction. So it's going to function like an open switch, right? An open circuit. And so if you look at it, it's just copying the voltage input, the voltage output, sorry. The voltage output is just copying whatever it's receiving from the voltage input. So it's just going to copy the graph, right? And you see this is the positive clipper because it removes the positive region. It retains the negative region, right? And it's kind of intuitive because the diode is pointing down. So this is where you're going to retain. And this is the same case for the reversed one. The diode is pointing up. So in this case, you're going to save the one that's positive, right? And so let's now introduce our bias voltage. I've still notched the voltages here. And then this one is a bit trickier uh to analyze because we now have a voltage that we're currently measuring, right? So in the positive half cycle, what do you call this? There's enough voltage in here. There's enough voltage in here so that it's going to copy, what do you call this? It's going to copy, actually, wait, hold on. All right. So the thing that you notice here with the bias voltage and the diode is that they're in series, right? And so you can interchange their positions. I'm gonna do that right now because this is what I do in the analysis portion. So it's like that, right? And so if you notice, this bias voltage, it kind of looks like a voltage drop if the direction of the current is like this, right? And so let's say this is 3 volts, right? And what's starting to at the start of the transmission of the voltage, it starts at 0, right? And becomes 1, 2, 3, 4, 5. At 0, there's going to be a voltage drop here. So 0 minus 3, that's -3. That's not going to allow uh that's not the correct polarity for the diode, right? So it's going to open. So it's going to open. Let's just say it's like this. Right? Yeah, it's going to open like this. And so if it's open, it's going to mirror the same thing that it did for the parallel clipper, right? So if it's going to open, it's just going to copy whatever it is that you're inputting, right? And this stops just at the point where uh our voltage here, the voltage input that we have is 3, because 3 minus 3, that's 0. I mean, still that's going to, what do you call this? That's going to not be enough for the ideal diode, but still. Now we go on to, let's say, 4 volts, right? It keeps on increasing, right? 4 minus 3, that's 1, but 1, that's enough for the ideal diode, right? That's more than 0. And so what happens is it functions as an open circuit. It functions as a closed circuit. The circuit completes itself. But now, let's see here. We're measuring this thing right here. We're measuring the 3 volt voltage drop, and then the ideal diode, which has no voltage drop, right? So what are we measuring here? Only the 3 volts, right? According to KVL, that's only 3 volts. And so it stops at this region, right? This is 3 volts, and this is like 5. And so it stops at that region until the voltage is not going to be enough to counter the 3 volts. And so everything just copies the normal waveform, right? And so I think Bricks and I call this the toll gate, the toll gate analogy. Like if you pay enough here, it's going to open. If you pay enough voltage here, quote unquote, it's going to open. The diode is going to close the circuit, and you're only going to measure the voltage drop here. It's the same thing if you make it -3 volts. Let's say we reverse the polarity. So I'm going to actually remove the thing. Yeah, there. And then this is going to be -3 now, right? And so the clipping line here, oops. So the clipping line here is going to be -3, right? And anything below it, that's what stays. So that's going to be our output waveform. And so it's the same for the other one, for the other side, but instead of saving the one below, we're going to save the one on top. So this is 3 volts, and then we're going to do this, right? And if it's -3 volts, we're going to save everything on top here, like that until it stops here. And then we peak at, not, this is not peak. We reach rock bottom at -3, and then we come back at 0. All right, that's done. The parallel clippers are done. Now let's go on to the clampers. So the main difference between a clipper and a clamper, of course, is the addition of the capacitor, right? I won't analyze this. What do you call this? I won't analyze this very in depth because that takes, like, I don't know how long are we recording currently. We're recording at 19 minutes. So our reviewer, which we're going to release soon, contains an explanation as to how clamper circuits come to be, right? But basically it works like this. So the direction of the diode here is where you should start clamping. Clamping means basically like this, right? There's no bias voltage here first. And so let's refer to our peak voltages here. This is 5, this is -5. Okay, just for clarity. If we clamp down, there's no bias voltage, so the clamping line is at 0. Okay, that we start there. If we clamp down, this should touch the clamping line should touch the highest point of the waveform, and you're going to translate it accordingly. So it's like that. So now this starts at -5, and it goes to 0, -5, -10, -5. That's how you clamp, right? It's very weird. It's like whatever the bias voltage is, you what do you call it? You slide it down until it only touches the clamping line. And it's the same here. If the direction of the diode points upwards, you start the clamping line there and it has to touch the lowest point, right? So instead of 0, 5, 0, -5, 0, it becomes 5, 10, 5, 0, 5. Right? Sorry for the wonky drawings. I'm just like I just want to teach how the intuition works. Right? And so we approach the final one, and I think I just have to review so that yeah, I understand. Yes. Yep. Uh-huh. Okay. So, we have a 3-volt bias voltage here. And so we're going to thank you. Yeah, 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 yeah. Okay, so now instead of the clamping line being 0 volts, the clamping line is now at 3 volts. So since this diode is pointing down, that this means that the highest the highest point of this graph has to touch 3 volts, right? So instead of what do you call this? The highest point here being 5, the highest point should now be 3. And then we base our waveform on that, right? So instead of you notice that it just is a decrease by 2, right? And so instead of 0, you come at -2 up to 3 and then back to -2, and then I think this is -7. Yeah, and then back to -2, right? So that's how you clamp. Uh, and then let's say our bias voltage now is -3 volts. So it's going to go here. The clamping line is going to go there, and the highest point should touch this clamping line. So our highest point here is 5, and then our highest point now should be -3. So it's a decrease by 8. So instead of 0, you're going to go -8 to -3, back to -8, and then down to -13, right? And then back to -8, right? That's how you do it. That's how you clamp. Now, for the diode, for the clamper that's pointing up, so now the lowest point should touch the clamping line, right? So 3 volts again. This is 3 volts. Now the lowest point is -5. And so it has to touch 3 now. So it's an increase by 8. So instead of 0, we're going to come at, I think this is 8, 8, 13, 13, back to 8, and then down to 3, and then back to 8. So we're going to repeat that. We're going to repeat that for when this reverses its polarity. This is now -3. -3 go. And we notice that the lowest point here is -5. Now it has to be -3. So it's an increase by 2. Right? It's an increase by 2. So instead of 0, we're going to come at 2, 7, and then down at 2, down at -3, and back at 2. So that's it. That's our intuition for our clippers and clampers. So ayun nga, most likely in the quiz, we're not going to encounter ideal diodes at all. We're just going to encounter like silicon and germanium diodes, and that's okay because let's say na ganito nga, let's say this is silicon. Uh we can just express this like just a normal, sorry, not normal, an ideal diode, and then we add and then we add what do you call this? A voltage drop, right? A voltage drop that has 0.7 And it just functions the same way as this thing. Right? So that's covered in our topic. Right? That's covered in our discussion. So I just wish everyone good luck because this is so confusing. Like uh discussing this right now, I can't believe I've done something like this. It feels like an achievement. But yeah, I think that's it. If you guys have any questions or like any clarifications, don't hesitate to message me, and just wait for our reviewer on diode circuits. This is going to be from yung diode analysis, and then analysis for the output waveforms of clipper and clamper circuits. So just stay tuned for that. And I guess that's it. So thank you guys for watching. And ayun, other topics, just message me if there are any requests. And I think that's it. Thank you guys. Keep learning. Oh man, it's like 150. Oops.